Okay, guys, greetings once again, and welcome to another edition by iCampSA. In this lesson, we are looking at statistics, and our focus is on linear regression. This is grade 12 mathematics, and we'll explain all what you need to understand about linear regression and work through past paper problems. We'll do about 5 past papers, so do make sure that you pay attention. So let's start from the beginning. Remember, we said that our focus is linear regression. So whenever you see linear, what I want you to remember is something that you had learned back in the days, and that is a linear equation. So a linear equation, many of you know it as a straight line. Okay. And this is where really we are going, because with linear regression, what we are trying to do is we are trying to determine the relationship between two variables. And those variables, for our case, it will be x and y. Okay. And what you should be able to see and what you will realize is that the relationship between x and y is a linear relationship. So it is a linear relationship, and that is why we are going to be focusing on linear regression. Okay. So other relationships you can be able to find, but what I need you to remember is that whenever we are talking of a straight line, we're looking at m is mx plus y equals mx plus c. Okay, where your m speaks to your gradient. Okay, and then your value of c, that speaks to your y-intercept. However, for the purposes of our course, or rather for linear regression, we are going to use a slightly different expression. And for linear regression, what we are going to use is this expression. We are going to have y equals a. So we are going to have y equals a plus b times x. Okay. So this is what we are going to use. So we are going to use this expression. So essentially what we will be doing with this expression is we'll be taking data and then fitting the data into this expression. So what will be happening for the most part of our problems is that we will be given data. So in order for us to understand what kind of data we'll be looking at, we'll consider let's say we have a shopping example. Okay. And in this shopping example, what we are looking at is x, where x is the number of items, okay, that a person is picking up. And then we have y, where y speaks about the time in seconds taken to pick up a certain number of items. So we have the time in seconds. Okay. So what you will realize is I'll quickly draw my table here. So for our example, we'll look at, let's say for example, we are picking 5 items. And for 5 items, or for a specific 5 items, we take 3 seconds. Then we'll look at when we are picking up 8 items and we happen to take 11 seconds for these ones. And then this person is doing shopping for a set of 12 items. For these 12 items, they happen to take 9 seconds, and then they pick up 15 items. And for these 15 items, they take 6 seconds. Then another 15 set of items, and they happen to take 15 seconds. And then for another set of 17 items, where they happen to take 13 seconds. Then there's another set of items, which is 20 items. And for these 20 items, they happen to take 25. and then they pick up 21 items. Then for these 21 items, they happen to take 15 seconds. So what we want to ask ourselves with linear regression is, what is the equation that describes the relationship between x and y? And since we are dealing with linear regression, that equation will simply be y equals a plus bx. And there's a name for this equation. What you will see when you are answering question is that this equation here is called, so this equation there is called the equation, so that is called the equation of the least squares regression line. So they call it the equation of the least squares regression line. Okay, so when they say determine the equation of the least squares regression line, it means what you need to figure out is the b, and you also need to figure out the a. Okay, so that is what we are going to be doing for most of the time. So we now know what the equation is and what we are dealing with. Now let's jump into correlation. So we have what we call correlation. And what correlation is it speaks to how much the data is related, or how much x and y are related to each other. So that is what this is doing. So it speaks to how much x and y are related to each other. Okay, and also what is also important is how much this x and y fit into a straight line. So this also speaks to and how much the data, which is x and y, fit into the straight line. And by straight line, we are talking about the line of the least squares, or the least squares regression line. So essentially, you know, how accurate does it fit into y equals a plus bx? That's the question, right? So for correlation, we have different types. Okay, so I'm just going to draw some couple of graphs here, right? So we have correlation that looks like this here, where let's say we have data, we have x like this, x like that, okay, like that. And what I need you to note is if we draw a straight line like that, you will see that the points are very close to this straight line that we have here. Okay, so whenever we have a situation like this, so what you would have, obviously on the horizontal axis, you would have an x, and then on the vertical you have a y. Then this blue equation here is described by an equation y equals a plus bx. Okay, so that is the regression line. So whenever you have the points being close to the blue line like this, what we will call this kind of correlation, we will say it is a strong, because the x's, as you can see, the data point, they are very close to the line. So it would be a strong, because of the slope, it will be a positive. So it will be a strong positive correlation. Okay, then let's try another one. So let's say we have another line like this, okay? And then what we have is we have points that say are coming out in this direction. Okay. And then you fit a straight line, the blue, like that. And you'll see that these points are very close to the blue line. Okay, so obviously the blue line is described by y equals a plus bx. That's our regression line. On the horizontal axis, you have x. On the vertical, you have y. Okay. So if you look carefully, we have a negative slope, but the points are very close to the straight line. So this becomes still a strong correlation. So we have a strong, but the gradient is negative. So we'll have a strong negative correlation when we have these kind of points. Okay, so let's go to the next one and have a look at other types. The next page. So let's quickly draw our Cartesian plane again. And let's have, say, an x here, x here, x here, then x here, then x there, then x here, then x here, then x here. So if you observe carefully, you will see that even if you wanted to draw a straight line somehow, for whatever reason, you will see that what is happening is you don't have correlation here. So, or your correlation is very weak. So if you look carefully, you'll have y is ax plus b. Here we obviously have x. We have y. So in such a case, what you should realize is that you have a weak correlation. So what we will say is we have a weak, but because the slope is positive, so it will be a positive correlation. Okay, that is what we have. It's weak, but it is, a positive correlation because of the slope of that line when we draw it. Right. Then let's assume we have another case where we have our data. So yeah, say it's looking something like this here. And yeah, it's looking something like this somewhat. So if you look carefully, if you try and draw a straight line, it really doesn't fit into this data. So what this means to us is we have a weak correlation. So we'll have a weak, but look at the slope. This is a negative slope, okay? So we will have a weak negative correlation. Okay, so that is what we have there. So obviously this is y and this is x. Okay, so that is what we have. Then if we have no relationship at all between data points, then we are going to say there's really no correlation. Okay, let's consider an example like that where it's just too random. Okay, so you have an x here, one here, one here, one here, one here, one here, one, say one here, and yeah, something like this. So if you look carefully, if you were to try and fit in a line here, the data is just all over the place. So in such a case, what we would say is, there's no correlation. Okay, so that is what we would say. But now we need to ask ourselves about this correlation thing. So we need to ask ourselves about correlation. And while we are thinking about correlation, there's something that we need to know, which is that in order for us to be able to figure out the correlation, we can use the regression coefficient. So if we are questioning that, so what we should do is use the regression coefficient, and that coefficient is named R. Okay, so here's a couple of notes that you should make, which is that, let's start here with R, which is that our R is always between -1 and +1. Okay, so let me create some space. So that is very important for us to make a note of, which is that our R is always between -1 and +1. Okay, that's one note. And then what we should also note is that when R, so R is close to -1, when R is close to -1, then what this suggests is that we have a strong negative correlation. So we have a strong negative correlation. Okay, this is very important for you to note. And then when R is close to +1, I'm sure you can take a guess. It means we have a strong close to +1, so that should be a strong positive correlation. So in order for our data to be very close to, or in order for our least of squares equation to be accurate, we need to have a strong correlation. Okay, let's look at other cases. So if R is negative, okay, but close to 0, what you should notice, it's negative but close to 0. So what this means is we have a weak correlation, but because it's negative, it's going to be a weak negative correlation. So we have a weak negative correlation when R is negative, but it's close to 0 than 1. Okay, then let's have a look at another case where we have R is positive, but it is close to 0, the value. Okay, so if that is the case, we know we have a weak correlation, but because R is positive, we have a weak positive correlation. So we have a weak positive correlation. Okay, and then the last part is when R is 0. So when R is 0, what that means is we have no correlation. So there's no correlation between X and Y in whatever data that we are given. So no correlation. So this will be very important to keep in mind when we are now doing problems. Okay. So with this understanding of correlation, we now are in a position to be able to go and engage in questions. Okay. But before we do that, you just need to note that whenever we have a strong correlation, what that means, it means our equation y is a plus bx will estimate whatever that we are looking at accurately. Okay, that is what it means when we have a strong correlation. So just keep that in mind and you will see when we start doing problems. But what is very important in this part of the course is for you to be able to use your calculator. So for the most part here is we will be using your calculator. So for this section, it's really straightforward. We'll be using your calculator. And what I need you to ensure is make sure that your calculator is in stats mode. Okay. And then when it's in stats mode, we'll be able to use the table as I will show you on my digital calculator. Okay. So with this in mind, let's go and solve some questions, guys. And the first question we need to deal with is from 2025 November exam. So in this exam, we are told there were 11 cars of the same model for sale at a car dealership. Okay, let's just make that. And they are saying the age and years of each car and its corresponding selling price are provided in the table below. So what we are going to do to make our life easy, we are going to say this is X, which is the age of the car in years, and then this is Y, which is the selling price of the car. Okay. Then they say determine the equation of the least squares regression line. So remember, we did speak about this previously, 1.1. So whenever they speak about the equation of the least squares regression line, they're talking about y equals a plus bx. So essentially, the question that we need to ask ourselves is, what is A going to be? And what is B going to be equal to? So in order for us to answer these questions, what we are going to do is to use your calculator. Okay, so let's go ahead and use my calculator. So this here is my calculator. I'm going to put my notes on the left, okay? So what you should do is you should make sure that your calculator is in stats mode. Okay, as you can see, mine is a stat there at the top. And what you do, you just do Shift 1, and then you go and look for where you have your AX plus B. Okay, I found it on my case. And what I'm going to do is I'm going to put X on the left. So when you put X, you put in the number, you click equal, then it goes to the next one. So we have a 2 equal, it puts in the 2. So we have a 3 equal, we have another 3. Then we have a 4, a 4, a 4. And then we have a 6, a 6. Then we have a 7, a 7. Then we have an 8. Okay. Then I scroll up, then I go to the Y part. I put in the numbers that I have there. So if you look carefully, it's 293, 123. And then it's 265, 123. Then it's 256, 123. Then it's 219, 123. And then it's 241. And then it's 246. And then it's 226. And then you will see we have 176. And then we have 154. Then we have 180. And then we have 148. Right. Once you've put in all of these numbers on your calculator, you can now click AC. Okay, then the AC makes this to disappear. Then you do Shift 1, and then you will select your data. For my case, I can go straight to regression, and you will now be able to click the value of A, and now it's saying it is empty. So let's see something. So let's go and, right, so okay. So I now need to quickly populate my table. So we have 2, 3, 3, and then 4, 4, 4, and then we have 6, 6, then we have 7, 7, and then we have 8. So it didn't capture my data, so we have 293. No, let's fix that. 293. So I'll quickly type in this again. Right, so our data is now up, guys. I'm done typing, so I'll go Shift 1 and then go to regression. And what I'm going to do is to read off the value for A. So if you observe carefully, we now have value for A. So the value for A, I'm just going to round off to 3 decimal places. If you look carefully, that is going to be 0. That is going to be, no, it's not 0. So if you look carefully, that is 3, 3, 1, and then 3, 9, 7 point. If you observe carefully, that will be point 19. Okay, but that will just be point 20. Okay, if we just make it to be that, and then we can now go ahead and read our B. So Shift 1, regression. So the value of B, if you look carefully, that is minus 22,000, and then we have 988 point. If you look carefully, that will end up being 32. Okay. So this means we are now in a position to easily go and write our equation. So this means our equation, therefore, will be y equals, remember we have A, so that's 331,397.20, and then minus, remember it's supposed to be bx, so the b is 22,988.32, and then times x. Okay. So that is what our equation becomes, and we are happy. So that is our equation of the least squares regression line. So let's go to 1.2. So in 1.2, they are saying predict the selling price of a similar car at this dealership, which is 5 years old. So essentially, remember, they are looking for the selling price, which is y. So they are asking us, what is y given that x, which is the number of years, that is 5. So all what we are going to do here is to use the equation. Okay, that's what we are going to do. So I'm going to do y equals 331 and then 397.20, then minus 22, then 988.32 into 5. Okay, that's what I'm going to do. So let's quickly go to our calculator. So if you quickly look at the answer which we get, we end up finding that y will be, if you observe carefully, let's expand that. Right, you will see that it becomes 216,455.6. Okay, so let's close that. You will see that what you end up getting is 216,455.6. Okay, so this becomes the price that the car will be selling at, which is 5 years old. Okay, so that will be our cost for this car here. And then now what we are asked to do is to use the correlation coefficient. Okay, so remember previously we spoke of the regression coefficient, which is the same as the correlation coefficient. So this here can be said to be the correlation coefficient R. And remember we spoke about R, if it's close to 1, means strong, then depending on a plus or a negative, then that speaks to negative or positive correlation. So they are saying use the correlation coefficient to show whether the prediction in this is valid or not. So let's look at 1.3. So the first question we need to ask ourselves is, what is the correlation coefficient? Because if the correlation coefficient tells us that this is strong, then we can believe the approximation of this equation. So let's quickly go to our calculator. So I will need shift 1, and I need the correlation coefficient, which is R. And look at our correlation coefficient, R. So you will see that R will be equal to negative 0.9. If you round off to 2 decimal places, that's 4/8. So that is just going to be 5. Okay, so that is what we have. And if you look carefully, this correlation coefficient is very close to -1. So what we can see here is that we have a strong negative correlation. And what we should note is that whenever a correlation is strong, then the prediction is accurate. So we can say the prediction is accurate, okay, because they said valid or not. So let's say the prediction is valid. Let's use their own term, okay, because the correlation is very strong, okay. So that answers that question. And then let's go to the next one. So what I'm going to do is to quickly make some space here, okay. Right. So let's have a look at 1.4. So 1.4, we are told use the answer in 1.1 to write down the estimated average yearly decrease in the selling price of these cars. So now I need you to think carefully, okay? The estimated average yearly decrease in the selling price. So think of this carefully. So all what they are asking here is the change in price over the change in years. So essentially this becomes M, which in our equation, the gradient, we know it is B. So this just becomes B. Okay, so this means we can look carefully and see that our B for our problem is negative 22,988.32 rands. So what this means is the yearly average decrease on the price over the 11 years, it is this 22,000. So we can say answer. And what we can say is that the yearly price decrease is this gradient of ours. It is 22,988.32 rands. This is the yearly price decrease, okay, over these 11 years. So I hope that this portion does make some sense to you. Right. With this said, let's go to the next question. And the next question comes from the June 2025 exam. So we are required to draw the scatter plot on the provided answer book, right? So what is going to happen here is I don't have the answer book, so I'm just going to draw this scatter plot a bit roughly, right? So what I'm going to do is I'm just going to have a line going all the way down. Let me create some space and then push it like that. And sorry, let's push it maybe one up. And then we just need another one going horizontally like this. Then now we can go ahead and do this. So if you look at our X values, we have X values from 3 up until the largest one is 20, okay? Then if you look at the Y values, the biggest Y value is 11, right? So on the vertical axis, I'm just going to try and have 11 points. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10, then 11. Maybe I can put in 12. That's okay. Then we know we have y there. Then on the horizontal axis, we have x. So for the x's, we said we're ending at 20. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that's about 20. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, then 20. Okay, not drawn according to scale, but hope you guys get the point. And then what we have here, that becomes x, and that is just the number of items. Okay, so I'll just say n of items, and it's very important that you label your x's. Okay, and then on this axis we have y, so we are just going to have y. And if you look at y, that is the time in minutes. Okay, so you will just need to make sure that you do note that time in minutes. So with this in mind, now let's go ahead and quickly plot this. So the approach is very simple. You would be having a pencil. So I'm going to start with 10. So if you look carefully, we have a 10, and 10 is a corresponding y value of 5. So I would go about this way. And then what I'm going to have is I'm going to have a circle there. And then I just delete these. Okay, delete. Done with that. And then the next one, so you can obviously shade here. So you can just quickly shade and have a dot. And then we go to the next one. We have a 3 and a 5. So 3 is here and 5 is there. So I can make a circle, small one, like that. Then I know I can just remove these lines. And yes, that is our point round about there. Okay. And then I'm just going to go to 20 and then I'll populate the rest. So 20 is here. Then 20 corresponds to a 9. So 9 is here. So where they meet, I'm just going to have a circle like that. Then I can delete this and delete that. Okay. And just shade our circle. Right. Then if you look at the next one, we have a 14. So there's 14 there. 14 and 7. And here's 7 here. So we can go ahead, make a circle there, then delete these two lines because we know our 14 and 7, and then just shade that. Okay. And then we can go to the next one, 17 and 6. It's very important that you draw all of these. So 17 is somewhere here. And 6 is somewhere there, right? Then if you look at where they meet, we have a circle. Then I can just delete these lines here. So let's shade here. Okay, that is a 17 and a 6. So I'm going to do the remaining ones. So let's now draw the last point together, which is 19 and 12. So if you look carefully, there's 19 and there is 12. Okay, so we are going to go and make a circle. Then we just delete these lines and you will see that that is our 19 and 12. Okay, so essentially that would be how your scatter plot looks like after drawing it on a graph that you would be given, or a table or a graph paper. So it would look according to scale, but yeah, I think here we tried. So let's have a look at 2.2. So 2.2, let's make our pen big. So in 2.2, we are required to determine the equation of the least square regression line. So they want us to figure out what is A plus BX. But the question we need to answer is what is A and then what is B. Then we would have figured this equation here. Okay. So what I'm going to do is to go to our calculator. Remember, we said for this part of the course or this section or for this topic, what you need the most is your calculator. So let's go and get our calculator, which is this one. And as done previously, guys, what you should do, you should go to your table. What did I just do now? Shift 1. You should go to your table, AX plus B. And then what you want to do is to populate your table. But what I'm going to do is I'm going to try, see this equal to, yes. So let's go and populate our table. So you'll see that I'll have 10 equal to 3 equal to. So I'm putting the X values, okay? So you should also on your casual do the same thing. So I have 10 and 3. Then I have 20 equal to. Then I have 14 equal to. 17 equal to 9. 12 and then 18 and 15 and then 19. Okay. Then what I'm going to do is I'm going to put in the corresponding Y values. So I have a 5, a 9, a 7, 6, 8, 11, 10, and 12. Okay. Once I'm done with this, now I can go and read my values. Shift 1, and then we can go and get our A, right? So if you observe carefully, you'll see that the value of A that we are getting is 3.07. So this one here is going to round off to 1. So it's just going to be 80, okay? And then for the value of B, let's go Shift 1, then read B. So for B, if I want this to be 3 decimal places, then it's going to be 0.352. Okay, that is what it's going to be if we want to make this to be what? 3 decimal places. Okay, so this means that our equation, which is what they are looking for, y, it will therefore be 3.080 and then plus 0.352 multiplied by x. Okay, so that is what we have as our equation. So then let's go to the next page. Then they say write down the correlation coefficient for the data. So this is 2.3. So in 2.3, what they are asking us is, what is R equal to? And guess what? Once you have your data in your calculator, that is very easy to read. So let's go back to our calculator. You clear Shift 1. Then you'll see I am able to read the coefficient here, which will become what? 740, 10 to the negative 3. So it will become 0.74. Okay. So if you observe carefully, you will see that the value of R is 0.74. So let's have a look at the next question, which is 2.4. So for 2.4, we are told the supermarket received an online order for 13 items. Remember, for X, we're looking at the number of items. And then for Y, we are looking at the time it took to pack those number of, or to get those number of items ready. Okay. So now the question is saying, the supermarket received an online order for 13 items. Predict how long in minutes it will take to prepare the pack. So essentially what they are asking us is y, because y is our time in minutes. Okay, so we know that our equation is y equals ax plus b, which happens to be 3.08 plus 0.352 times x. And guess what? We are given that x equals 13 items. So this means we can find y by simply having 3.080 plus 0.352 into 13. So I'm quickly going to use my calculator. So we have 3.08 plus 0.352 times 13. And the answer which we end up getting is the following. So I end up getting y equaling 7.65. Okay. So that is what we end up getting. And this here becomes our answer. So our answer is that it will take approximately this amount of time. It will take approximately 7.65 minutes to prepare this order of 13 items. So it will take this amount of time. Right. Done with this. So now we need to look at the next question. So which is, explain why the y-intercept of this least squares regression line does not make sense. So let's have a look at what is happening. 2.5. So remember our equation is 3.08, then plus 0.352 times x. So remember, if you make x to be 0, this here becomes our y-intercept. So why does this not make sense? So remember, our y-intercept, we obtain it at x is 0. So this here would be at x equals 0. So why does this not make sense? Well, this doesn't make sense because when x is 0, meaning when orders are 0, it will take 3.08 minutes to prepare 0 orders. So what we can say is that the answer is this here. It does not make sense. Okay, that's the first thing. Then we can go to the because, and that is because when 0 orders are made, it takes 3.08 minutes to prepare whatever that is ordered, of which it does not make sense, because if we are ordering 0 items, why should it take 3.08 minutes to prepare that order? So that is why this doesn't make sense. So if you quickly look again at the English, the answer does not make sense because when 0 items are ordered, it takes 3.08 minutes to prepare. And that doesn't make sense because you have 0 items to pack, but you are taking 3 minutes. What is that for? So that is why this does not make sense. So let's go to the next question. So for this question, we're looking at this data here, and we are required to determine the equation of the least squares regression line. So let's take our calculator, okay, and shift 1. So what I'm going to do is I'm quickly going to punch in this with you. So shift 1, regression A equals. So let's quickly put in this because we are required to find the equation. So if you look carefully, split this for 1.1. What we want to figure out is what is A plus BX equal to. So in order for us to figure this out, we need to figure out what is A and what is B. So for us to do this, what you are going to do is to use your calculator, as I'm going to do. So let's have a look. So we have X and Y. So at the top on X, if you look carefully, we have 85, then we have 150, then we have 100, then we have 120, then we have 90, then we have 140, then we have 135, and then we have 105, then we have 115, then we have 160. Then next, which is our Y, we have 165, we have 325, we have 200, we have 250, we have 180, we have 285, we have 250, we have 170, then we have 230, and then 340. Okay, that's the last one. So now I can go ahead and find A and B. So shift, so equals 2. Why is it saying this is empty? Let me go and try this again. So if you observe carefully, I just had to go and retype my data so that it's in the table. So if you observe carefully, that's just what we have. And then we can now go to our regression variables. And you'll see that the value of A we have found. So A is equal to negative 43.72. Okay, 720. Then let's go and quickly find the value of B. So 1B. And if you look at B, you will see we get 2.360. Okay, so that is what we have. So we can now write our equation. Therefore, our equation will be A equals to, or Y equals to A, which is negative 43.720, then plus B, which will be 2.360 times X. Okay, that is what we have. And then we are required to draw the least squares regression line on the scatter on the answer book. Okay, so there's a couple of things that you can do in order for you to get this sketch right. So the first thing, if you go to your equation and you do your plots, you will be able to see that it will be going something like this, because you have other values that you have, values like your 60s and whatnot. So you can, let's say, take 60, take 80, and then take your 100, and so on, in order for you to draw your graph, accurately. But I'm just gonna put in a rough line like this here. Okay, so you can go ahead and try to make sure that it's 60, or at a value that is just not very far off from 100, and so on. Okay, so let's go then to 1.3. So on 1.3, we are required to predict the weight of an A4 book that has 110 pages. So remember, X has 110, X is for pages, and then Y is for weight. So remember that your X is for number of pages. Okay. So you're looking at your number of pages, which in our case now, they are telling us it's 110. And then y equals your weight, okay, which is what we don't know. So we have x, the number of pages. We're trying to figure out y. So that means I'm going to have y equals negative 43.72, then plus 2.36 into 110. Okay. So I'm just going to punch in on my calculator quickly. So we have minus 43.72 plus 2.36 times 110. And what I end up finding is about 215. So I end up finding 215.88. Okay. And remember, this is in grams. So we can now easily conclude, which is that the weight of 110 pages is 215 grams. So let's quickly put that. Our conclusion is that 110 pages, those will weigh 215.88 grams. Okay, that is our approximation. And then now let's figure out 1.4, where we are required to calculate the percentage increase between a book that has 110 pages and a book that has 130 pages. So the weight increase, that is what we are trying to figure out. We are trying to find the weight increase, but we are looking at the percentage. Okay, so what I need to figure out is the first thing, for a book that has 130 pages, what is the weight? Okay, so I need to figure out, we have x, which is 130 pages, but I don't know what is the corresponding weight. Okay, so it means I must use my equation first to be able to determine the weight, which is going to be negative 43.72 plus 2.36, then 130. So our y will be, so 130. So the value that I'm finding is 263.08 grams. So now the question then becomes, what is the difference, or what is the percentage difference between these two values? And the answer to this is very simple. If you remember how to calculate percentages or percentage difference fundamentally, then this problem should not be very hard. So in order for you to understand how do we deal with this problem, well, let's consider an example. So let's say you had a 2, then all of a sudden you have a 6. So now the question is, what is the percentage change? Okay, from a 2 to a 6. So how you would calculate this is as follows. Let's create some space. So you're moving from a 2 to a 6. So what you would do, you would say 6 minus 2 divided by 2, and then you multiply by 100. Okay, so if you observe carefully, 6 minus 2, that would give you 4. 4 divided by 2, that would give you 2 times 100. So that would just be 200%. Okay, so that is how we would determine that. So now that we understand that example, then we are in a position where we can now answer our question. Okay, so maybe another example. So let's say, for whatever reason, you're moving from a 7 to, let's say, 18. So how would you find the percentage change here? So you would say 18 minus 7, okay, and then divided by 7, then multiplied by 100. So let's give that a try. So you'd have 18 minus 7 divided by 7 times 100, and the answer ends up being 154. Okay, so let's create some space here. Sorry, it becomes 157. So your answer becomes about 157.14%. Okay, that is the increase. So with this now in mind, remember at 10 pages, we have 215 grams. Okay, so this means that what we are going to have is we are going to have 263.08 minus the 215.88 divided by 215.88 multiplied by 100. And this is going to be, let's go ahead and punch 263.08 minus 215.88 divided by 215.88. This is multiplied by 100. And what we end up getting is 21.86%. Okay, so that becomes our percentage increase. So I hope that this does make sense to you. And that brings us to the end of the 2024 June exam. Let's go to the next question then, which is the 2023 November exam. So let's see what they have for us here. So we are told truck drivers travel a certain distance and have a rest before traveling further. So a driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued with his journey. The information is as given below. So we have X and Y. Then they are saying determine the equation of the least squares regression line from the data. So 1.1, very simple. They want us to give them y equals a plus bx. But we know we need to go and figure out what is a and what is b. And guess how we find a and b? What we are going to do is to use the calculator. Okay, so let's go ahead and use our calculator. So let's go ahead and type our data. So we have 180 equal to 200 equal to 400 equal 600 equal 170 equal 350 equal 270 and then equal 300. And we go up. We now need to do the y, where we have 20, 25, 55, 120, 15, 50, 40, and 45. Okay, after doing that, you just click your AC, and then we go to our regression. So equal to, so it didn't pick up my data. So this calculator has issues. Let me retype again. Okay, so I'm done putting up my data. So we can go and read up our values. So for A, this is what we end up getting. So the value for A, so we're getting an A value of minus 23.85. Okay, and then, so let me make it 3 decimal places rather. So we're getting minus 23.846. Okay, then let's go for B. So there's our B. So if you look carefully for B, we end up having 0.227. Okay, that is what we have. So therefore we can write our equation. Y equals for A, we have minus 23.846 then plus 0.227 times x. Okay, so we're done with that. And then now we are asked if a driver took, we're looking at 1.2, if a driver took 550 kilometers, remember that's the distance, that is x, predict the amount of time that he should rest before continuing on his journey. So what we are given is that x equals 550, and we are required to figure out what is y. So remember we have the equation already, so we are going to say y equals that minus 23.846, and then plus 0.227 into 550. So I'm just going to quickly use my calculator, minus 23.846 plus 0.227 times 550. Okay, and the y that I'm getting is 101.00. Okay, if I round off to 2 decimal places. So what does this mean? It means if we look at our answer, the driver should rest about 101 minutes. Okay, so that is what this means. So the driver should rest for 101 minutes. Okay, that is what should happen. So I hope that this does make sense to you guys. Then let's have a look at 1.3. So 1.3, they are saying write the correlation coefficient. What are they looking for? Essentially, they are trying to figure out what is R. So let's go to our calculator and quickly see what is R. So shift 1, R. So there's my R from my calculator. You will see that what we have is, you will see that what we have is R. We have R equaling 0. If you look carefully, 98. Okay, if I just round it to 2 decimal places. And what does this R suggest? It's very close to positive 1. So this means that we have a strong positive correlation. So 1.4. So they are saying we should interpret the answer that we have here. Okay, so essentially the question is, what can we say about this R value? So what can we say about an R value that is 0.98? That is the question. And the answer to this is very simple. And that answer is we have a strong positive correlation. So the R value indicates if you observe carefully, a strong positive correlation. So that is an answer is good enough. Okay, I hope that you guys understand. And if you were writing this paper, you were going to ace it. Okay, now let's go to the next one. So next, guys, let's have a look at question number 1. This is from the 2023 June exam. And the statement reads, the owner of a small company wishes to establish whether advertising in a regional newspaper is effective. The table below shows the amount spent on advertising and the corresponding sales figures for the last 9 years. Okay, so we're given the table where at the top we have X and at the bottom we have Y. So we are required to determine the equation of the least squares regression line for the data. So this is very simple, 1.1.1. What they are trying to figure out is what is A plus BX, okay? Which ultimately gets us asking the question, what is the value of A and what is the value of B? And remember, For these guys, what we do is you should use your calculator. Okay, so I'm gonna go ahead and punch on my calculator. So what you can do, guys, as we did before, you can put in your data. So you have X, that is 21,300, and then you have 23,700, and then if you look carefully, you have 24,800, and then the next one is 30,540, then you have 24,100, then you have 40,680, and then you have 22,400, then you have 35,250, and you have 29,110. Okay, then you go now, you deal with your y's, which is at the bottom, so that's 311,500, and I'll just populate the rest. You would do the same. You type the number, you click equal. So I'm done writing up our data, guys, in our table. So we can go and read up our values for A and B. So if you look carefully for A, we're getting that. So for the value of A, we are going to have 1,000. If you observe carefully, 730.22, and then this is going to be 5. Okay. Then let's go for B, shift 1, then we go for B. And if you look carefully, for B, we are going to have 13.960. Okay, so this means we can now write our equation. So therefore, our equation Y will simply be 1,730.225, then plus 13.960 times X. Okay, that is what is happening. And what I need you to remember, in 1.1.2, we are required to predict the sales if the company is going to spend 228,000. Okay, so remember, what we are given here is X, which is the amount spent, which is 28,500. And what we are required to figure out is, the sales and rents which we are going to close, which is Y. So that means we are just going to use the equation Y equals, we have 1,730.225, then plus 13.960 into what we have here, 28,500. So let me use my calculator. We have 730, then 0.225 plus 13.96, and this will multiply 28,500. And the answer which we get is our Y becomes 399 and then 590. Okay, 0.23. Okay, we round it off, right? So that is the sales that we are going to close if we have that amount of budget. Okay, so that becomes our answer. So I hope that this does make sense. So that there speaks to the sales, right? So let's go to the next question, 1.1.3. Write down the correlation factor. So what they are looking for is R. So we'll go to our calculator and shift 1. Then we look at R. If you look carefully, that's 980. So this will just be 0.98. Okay. So our R value will be 0.98. Right. Then we go to 1.1.4, where we are asked to describe the association between the amount spent and the sales closed. So what you should see is they are just trying to ask us a question. What is the relationship, between x and y? So above we have the correlation factor. Look at the correlation. That's 0.98. What does it mean? It means we have a strong positive correlation. So what we can say as our answer is the following. So answer, we can say that there is a strong positive correlation between what and what. So there's a strong positive correlation between, if you observe carefully, the amount spent, between the amount spent on advertising and the sales that these people close, okay? And the sales figures. Okay, this is as simple as we can write it to be. So there is a strong positive correlation between the amount spent on advertising and the sale figures. So meaning the more amount of money they spend on advertising, the more sales they will get. Okay, so I hope that this does make sense, guys. And this brings us to the end of the last example for this lesson. So we've done 5 papers. I hope that you will be able to get all the marks for questions that are related to linear regression. So what's very important is to understand these fundamental concepts that we try to cover in our introduction here. Make sure you understand correlation, the value of B, how do you determine it, the value of A. If the correlation factor is close to +1, what does it mean? Close to -1, what does it mean? Close to 0, what does it mean? And this here, guys, brings us to the end of the lesson. Cheers. I hope you enjoyed.